All right, so we were just talking about this, that eventually the oceans form. There's it's not just from the water that comes from volcanoes. Some of the water comes from comets and asteroids that crashed into the early Earth, and there's still asteroids and comets crashing into the Earth, just not as frequently. All right, for the oceans, so right off of the coasts, you have what's called the continental margin. And so the continental margin is just like the margin, around a piece of paper. It is the outer edge of the continents. All right. So it's composed of three different parts. So the continental margin has what's called the continental shelf. So this is just kind of an extension of the continent out into the ocean. The ocean has risen high enough to cover this up, right? Remember, in different periods, this is kind of referring to chapter 21, or I'm sorry, chapter 23. At different periods, the continental shelf may be exposed, or covered with water. All right. So anyhow, we're going to go with the continental shelf being covered with water. So this kind of is it's a gentle slope away from the continents, and then there's this very very sharp slope called the continental slope. Okay, so that's going to be at a very great angle, and then at the bottom of that, or towards the bottom of the continental slope, you'll have a bunch of sediment that builds up. Dead marine life will build up right here, and that's called the continental rise, and that's at a much smaller slope, and that kind of leads us into the ocean basins. All right, and then from the ocean, so in the ocean basins, there's these really flat regions called the abyssal plains. All right, so these abyssal plains are some of the flattest regions on the planet. Of course, they're deep beneath the surface of the ocean, and then of course you have the mid-ocean ridges, where you have volcanic activity, mountains. Oh, and these abyssal plains. There's also like abyssal mounds, which are just these little kind of like little hills that lead up to the mountains. Anyhow, you have the mid ocean ridges, which, by the way, are not always in the middle of the oceans. Like, for example, the ones in the Pacific are sometimes really a lot closer to the continents than they are to the middle of the ocean. The one in the middle of the Atlantic, of course, is pretty close to the middle. What would be considered the middle of the Atlantic. Anyhow, there's lots of volcanic activity there, because remember that this is where the ocean floor is spreading apart, right? That's what we call rifting, is the ocean is spreading. And then, of course, there's it's not really showing it here, but a little away from these, where this is happening, is these ocean trenches. We've already seen pictures of that in other chapters, but just keep that in mind as well. All right, so let's go into this in a little bit more detail. The continental margin is between the shore and the deep ocean basins. So again, it's composed of these three parts. The continental shelf, which is just kind of a gentle slope, as I just said. It's better to just look at the picture right here. It's kind of gently sloping down, now just to let everybody know, that not all the continents have a very great continental shelf. Like on the western coast of the United States has a pretty good continental shelf, but like right off the East Coast, it drops pretty dramatically into, it's so you almost it almost starts with the continental slope is much closer to the actual coastline. So you don't have to have that much of a continental shelf. Um, all right. Anyhow, and then of course the continental slope is you have a great angle, a very large angle that extends down into the ocean basins. But right before you get to the ocean basins, you'll see some. We see some what is called the continental rise, which is this accumulated sediments that fall down the slope, and this is like dead marine life that builds up there. So there's lots of calcium carbonate, right? That which like shells and things, and even bones of fish and things like that accumulate there. All right, just because it's falling down this very steep slope. If some fish or something dies right along there, it's going to drop down and accumulate here in the continental rise. All right, so then the ocean bottom has these, of course, these deep canyons, the trenches, crevasses. The underwater mountains rise upward from the seafloor, as it says here. So we go back to this picture right here, right around the mid-ocean ridges, which again are not always in the middle. Let's see, we already did this. The deep ocean basins. So this is where the seafloor spreading is taking place, and basalt is that's of course the magma that rises up from the interior of the earth, from the mantle, and the magma rises up and then cools and becomes rock, and that's the type of rock we call basalt. And basalt, of course, is more dense than the continental rock, which is mostly granite, and so the ocean basins are much deeper than they're more dense and what else did I want to say about that? Yeah, all right. So anyhow, that's where the seafloor is spreading. Abyssal plains. So these abyssal plains are really flat regions, and then of course there are anytime you have the seafloor spreading, there's always going to be ocean trenches, and these the sea mounts. These are just basically little hills that are usually at the edges of these abyssal plains. All right, let's see. So this is the flattest part of the ocean. I just mentioned that, and you get lots of sediment accumulating there. So even more so than the sediment at the continental rise. Let's see. So ocean trench, because it's bigger, right? There's more area there. The ocean trenches are usually really long, and that they're extremely steep. And remember, these are the deepest parts of the ocean. Like the Marianas Trench. You're talking about more than 11,000 meters down. As opposed to, like, for example, you compare that's the deepest part of the ocean, so it's 11,000 meters down, or approximately that much. And then, of course, Mount Everest doesn't even quite rise into the atmosphere. It's a little less than 9,000 meters tall. All right, so the ocean ridges are that's where you have these mountain ranges, the volcanic activity, tectonic activity. All right, so that these are all over the planet. you can kind of think of them like the seams on a baseball, right? So the baseball has the seams sewn all the way around, and you can see these ocean ridges going all throughout the oceans of the earth. The deepest parts of the ocean are the trenches, of course, as I mentioned before, right? So there's a good example right there. This is in the Pacific Ocean that they're talking about here. And what else? All right, so the shallowest waters are in the middle of the ocean, around the underwater mountains, near the ridge systems. All right. Ocean trenches are the deepest parts of the ocean because, let's see. So this is where the ocean crust meets the continental crust. No, that's not true. That's where subduction occurs. All right, that sounds pretty good. No sediment accumulated. No, that's not true. All the accumulated sediments. So I would say it is B. Yeah, there we go. All right, let's see. Characteristics of waves. All right, so now we're talking about the top of the oceans. So the waves get their energy from the wind. That's the critical part. And we're going to talk a little bit about waves here. So the top of the wave is also known as the peak of the wave or the crest. The bottom of the wave is also known as the trough. And like the distance between crests or the distance between troughs. Remember, waves repeat themselves. So the distance from one crest to the next crest is what we call the wavelength, or the distance between one trough and the next trough is also known as the wavelength. The wave height is the distance between the trough and the crest. So we just talked about that. The wavelength is the distance between it doesn't have to be two crests. It's any part of the wave where it repeats itself. That could be that's the wavelength. The period, of course, is the time it takes the wave to pass a certain point. So you have a point. You watch the easiest thing is to usually look at the crest, right? So the crest passes by, and then how much time does it take for the next crest to pass by? And that we call the period. All right, and so the ocean waves. We'll get to tidal. We'll get to the tides shortly. So the height, the length, the period of the wave depends on the wind speed, the length and time that the wind has been blowing, and the fetch, which is the distance that the wind has traveled across the open water. That's just what it's called. All right, so let's go. This is a nice picture of a wave. So this is from crest to crest. Let's see. So if you had if this wave extended, you could also go from trough to trough. That would be also the wavelength. So these water waves are actually, like, one of the things that people noticed very quickly is that, if you watch a stick or, something that's floating in the water and you got to be not right near the shore, but you just sit there and you watch. It turns out that the stick doesn't really go anywhere. Not from the waves, because these waves are actually circular. So they're making the water is going up and coming down, going up and coming. And so the actual individual molecules of water don't really travel very far. Not because of, not from the wave. The wave is just this disturbance that is passed along, and the water goes up and it comes down. It goes up and comes down. And it does make a little bit of a circle, but it doesn't really go all that far. All right, so that's important. So ocean waves are on the surface. They're what they call orbital waves because they're moving up and down. The wave energy moves forward, and the disturbance moves, but not the water, right? The actual molecules of water don't really, they move a little bit back and forth, but not much. All right, so this occurs in the open